Physics concept of fields. We look at the following outline: definition of field, examples of fields, types of field. Then we'll look at the gravitational field. Then finally, we'll look at calculations. Let's begin. Field. What is field? A field is a region in which each point is affected by a force. Each point is affected by a force. All right. For example, objects fall to the ground because they are influenced by the Earth's gravitational field. Okay. Now, a small object, metallic object close to a magnet is attracted by the magnet because it is influenced by a magnetic field. There is a field around an electric charged object. Okay. So any region in space under the influence of some physical agencies such as gravitation, electrical, and magnetism is called a field. Examples of field: we have the gravitational field, the electrical field, number three, the magnetic field, right? And then finally, we have a nuclear field. Types of field or kinds of field: we have the vector field and the scalar field. Let's begin with the vector field. All right, these are fields that require magnitude and direction to specify them. Okay, they need magnitude and direction. Vector fields are mapped by lines of flux or lines of force. Let's look at examples. Examples of vector fields include gravitational field, electrical field, and magnetic field. We also have distribution of velocity in a fluid as an example. Scalar field. These are fields that require only magnitude to specify them, to define them. Okay. They are mapped by different lines such as isothermal, lines of equidensity, and equipotential surfaces. Okay. Examples of scalar fields include distribution of temperature, density, and electric potential. Now let's go into gravitational field. What is gravitational field? At a point is defined as the force per unit mass that will act on a particular or the particle located at that point. The force per unit mass. Mathematically, G is equal to F over M. The force per unit mass that will act on an object. That's gravitational field. All right. Gravitation is the force of attraction exerted by a body on all other bodies in the universe. Newton's laws of universal gravitation states that the force of attraction between two masses, m and m, is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. We can express it mathematically as F equals G big M times small m all over rho square. The big M and the small m are the masses, the two masses. Rho is the distance between the two masses. while G is the gravitational constant, and it will always be given in calculation. All right, the unit is Newton meter square per kilogram square. The constant is given as 6.67 times 10 to the power minus 11. Right? Now, let's look at this small picture. The two masses separated by a distance r. Okay? So, the product of the masses and the square of their distance apart. Relation between the big G and the small g. The small g is equals to G, the big G times mass all over r square. Okay, note this formula. Gravitational potential. This is the work done in taking a unit mass from infinity to that point or to a point in the gravitational field. All right, you take a mass from a far distance to a point in the gravitational field. It is denoted by V, and the formula is G times M, the big G times M all over R. That's the formula for the gravitational potential, where M is the mass of the Earth, assumed to be concentrated at the center of radius R. Escape velocity. This is the velocity with which a body moves off from the effect of gravity. All right, velocity of escaping from where gravity is to where there is no gravity is known as the escape velocity. All right, we use v sub e to denote it, and it's given as the square root of 2 big Gm all over r, or we can also express v sub e as the square root of 2 small g r. Okay, now let's look at some calculations with the formulas we have gotten. Example 1, calculate the gravitational attraction between two spheres that are 8 meters apart and the masses are 30 kilogram and 22 kilogram. Don't forget G is a constant, 6.67 times 10 to the power minus 11. Solution. So we're looking for force, gravitational attraction, so we use Gmm over r square. We substitute our values. Big G is 6.67 times 10 to the power minus 11 times the big mass is 30, small mass is 22, divide by r, which is 8 square. Okay. All right. So if you multiply 6.67 times 30 times 22, we're going to have 44402.2 times 10 raised to the power minus 11 all over 8 square, which is 64. Okay. We're going to divide 4402.2 by 64 now with calculator. Then you're going to have 68.784 times 10 to the power minus 11. If we move the point forward in front of the 6 once, we're going to have 6.878 times 10 to the power minus 10. The power will reduce. Now the second example, example 2. The mass of the Earth, m, of radius 6.4 times 10 to the power 6 meter is 6.0 times 10 to the power 24 kilogram. Calculate the force per unit mass. Solution. The force per unit mass is G, because G is F over M, all right? And G is also expressed as Gm over r square. I've stated that before, okay? So let's substitute our values. G is 6.67 times 10 to the power minus 11. It's a constant. Times the mass is given as 6.0 times 10 to the power 24, okay, all over the radius square, which is 6.4 times 10 to the power 6, all squared. Remember, it will be squared. Now, if we multiply 6.67 times 6.0, we're going to have 40.02 times 10 raised to the power, you add minus 11 plus 24. The powers are the numerator. All over 6.4 square at the denominator. 6.4 square with your calculator will give us 40.96 times. Now, 10 raised to the power 6 times 2 outside will give us 10 raised to the power 12. Okay? Now, let's divide 40.02 by 40.96. Separate it. Then take one of the times. Take one of the 10 and then the powers minus 11 plus 24 and then minus 12 because we are dividing. Minus 12. Okay? So when you divide 40.02 by 40.96, we're going to have 0.9771 times 10 to the power minus 11 plus 24 minus 12 will give us 1. And when you multiply this, you're going to have 9.77 meters per second square. That's the unit of G. Now you're going to do the following exercise. Question 1, you calculate the gravitational force in question 1, right? Question 2, you are going to look for the value of G, small g, okay? The force per unit mass. And then question 3, you calculate the escape velocity, okay? In question 4, you're going to calculate the force of attraction between two masses that are given to you, and these two masses are separated by a distance, which is their radius, to get the value of the force in question 4. All right, the final question, you calculate the gravitational potential given the following parameters. Okay, to solve them and let me see them. Okay, okay. For more of our videos, ensure you subscribe our channel. Thanks for being a part of the class.